In this first problem, you were asked to make these evaluations of the function f of x when f of x is this piecewise function. Now again, the number that you have in here is just going to be plugged into this formula, but remember, which one of these three formulas you're going to use depends on the value of the number in meeting these conditions you see over here. So for f of negative 5, well, negative 5 is a value that's less than negative 3, and so you would substitute negative 5 into this, and you would get 20 as your answer. When you get to negative 3, well, negative 3 is not less than negative 3. So negative 3 doesn't fall in this category, it falls in this category, which means that now when you're substituting negative 3 into f of x, you're going to use this middle formula to do it. So the negative 3 is going to be substituted into this and calculated to be 3 halves, or 1.5 if you will. For negative 2, well, negative 2 is still in here, so you're gonna substitute it into the same formula and calculate that out to be 2. 0 also falls between here, so you're going to put the 0 into that formula and get the 3. 1 also falls there, and you're going to get the 7 halves. 2 is also still included, so it's still going to be using this here. And you calculate that, you get 4. It's when you get to 3 down here that you actually fall outside of this middle portion. So now you're going to be in this portion here, being greater than 2. So f of 3, you're going to do 3 times 3 minus 4 and get 5. And then for f of 5, again, you're going to substitute into this portion here and get 15 minus 4, or 11. Keep in mind that you may be asked these questions and that don't necessarily follow an order for x's. Just make sure that you're using the x value and the conditions together to decide which of the formulas you're going to use as you evaluate your function. For this one here, you do have a piecewise function. There are 3 pieces. Even though there's a connection here, you can see there's clearly a sudden turn here. So you have a piece here, a piece here, and a piece here. Because the two are connected here, you do have some variations about how to make the 4 statements. And of course, you might have some variations depending on whether you're going to use point slope or slope intercept at certain points. So I'm going to go over a few different scenarios here. So looking at this first portion that goes up until negative 4. Now for the sake of this, x is going to be considered to be less than negative 4 for this. Even though you see a closed dot here, I'm just going to assume it's less than negative 4 for this situation. As I said, there are going to be variations that I'm going to go over later where this might be different. So using this, and I see that negative 4, 8 is still a point that the line approaches, then picking another point, the negative 6, 9, I can see that the slope is negative 1/2. And using this point that I found, I'm going to write the equation of this linear segment in point slope. So you're going to have negative 1/2 times x plus 6 plus 9. Could have also used the negative 4, 8, but now you chose to use this. The middle portion, now for my purposes, I'm going to now include the dot with x. I do have a closed dot, so I had to show an inclusion of the dot somewhere. So I am going to have the less than or equal to appearing here. Now I could either have that here or here, one or the other, just not both. So between negative 4 and 2, I'm following this section here. Now this one here, I actually do have a y-intercept that happens to be at 0, and I can see that if I'm following this, I can see that the slope is a negative 2. So writing this in slope-intercept form, I would have y equals negative 2x plus 0. Well, I really don't need to put the plus 0 at the end, so the negative 2x is what I'm putting here. And of course, the third portion goes from 2 and beyond, so x is greater than or equal to 2 is what this is for. I can see that this one has a slope of 2 up to right 1. So the slope is 2. I'm going to use the 2, 1 as the point of reference. So as far as an equation goes, I'm going to have f of x or y equals 2 times x minus 2 plus 1. So this would be one possible answer. Another possible answer would be to have both of these also written in slope-intercept, so I could distribute and combine any like terms, and I would get these. And as I mentioned before, the other option is that this less than or equal to could also be up here instead. And that could also be with the original equations that you had over here too. So there's different variations that are acceptable for this, depending on how this was interpreted and where you're deciding the closed dot's going to go in this connected portion. For this problem here, you're told that a department store is offering a coupon for 20% off of any purchase over $100. So it has to be over $100 in order to get that 20% knocked off. So for a $20 purchase, you're still going to spend $20. For a $50 purchase, you're still going to spend $50. For a $90 purchase, you're still going to spend $90. And for a $100 purchase, since that's equal to $100, not over $100, you're still going to spend $100. It's when you get to 120 here, that's, well, any value over, I'll tell you that also. $120 purchase, you are going to be over that 100, so now you're going to get this coupon of 20% off. Keeping in mind that 20% off of the purchase means that you're going to be paying 80% of the total. So the total purchase is $120. You're going to be doing 80% of that, or 0.8 times that 120, and you get $96. For the $200 purchase, again, that's over 100, so you'd be spending 80% of that, which would give you $160. And even if you have $100.01 purchase, that is over $100. So you would do 80% of that, and you'd get about $80.01. So if you had a $100 purchase, it might be good to maybe make that purchase go up just a little bit more to go over that, so you could end up saving about $20 in the long run. So now, what's the piecewise function that describes that? Well, we could see that what we spent for the purchase is how much we had. So basically, f of x equals x for anything that's less than or equal to 100. When we got over 100, that's when we did 80% of that. So 80% of that is x is what happens when x is greater than 100. And so that would be the piecewise function that describes this situation. That is the end of this problem and the end of this video. If you have any additional questions, please bring them up in class.